For centuries, humanity has looked at Jupiter and believed it understood what it was seeing. A giant world of gas, storms, and violent weather patterns drifting through the outer solar system. A relic left over from the birth of the planets. But the deeper NASA's Juno spacecraft traveled into Jupiter's domain, the more unsettling the truth became. Because beneath the swirling clouds and endless lightning storms, Juno discovered something that no one expected. Not just chaos, but patterns. Not just motion, but rhythm. And with every orbit, Jupiter began to look less like a planet and more like a system operating with terrifying precision. As Juno entered the final years of its mission, the spacecraft moved closer to Jupiter's volcanic moon Io than ever before. During flybys between 2023 and 2024, it passed only around 1,500 kilometers above the surface, capturing enormous eruptions blasting lava far into space. But the strangest part was not the eruptions themselves. Several volcanoes appeared to pulse in synchronized intervals, almost as though they were following the same hidden timing mechanism. Near the giant lava lake known as Loki Patera, Juno recorded unusual magnetic disturbances at the exact moment volcanic activity intensified. Scientists expected random geological violence caused by tidal forces. Instead, they found coordination between eruptions separated by huge distances across the moon's surface. It was as if Io was responding to an unseen signal buried deep within Jupiter's influence. Juno's journey then carried it over Jupiter's polar regions, where massive cyclones spin endlessly around the planet's north pole. Infrared images showed enormous storms packed tightly together, rotating in near-perfect formation. But when Juno scanned beneath the clouds using microwave instruments, one cyclone behaved differently from all the others. Its center appeared strangely hollow. The visible storm existed on the surface, yet deep below there was almost nothing. No strong energy signature. No turbulent structure. Just emptiness. Some researchers privately described it as a mask, a weather formation that looked real from above while concealing something beneath it. Unlike every surrounding storm, it remained unnaturally calm and perfectly symmetrical. Far from the giant storms, Juno also detected strange activity from Amalthea, one of Jupiter's tiny irregular moons. Barely 84 kilometers across, Amalthea was never expected to hold scientific importance. Yet during one close orbital pass, Juno's infrared systems detected rhythmic bursts of heat coming from the moon's surface. The pulses appeared only while the spacecraft remained within direct observational range. Even more unsettling, the thermal bursts aligned almost perfectly with unusual magnetic waves moving through Jupiter's equatorial region. To some scientists, it looked less like a random phenomenon and more like a response. Jupiter's thin ring system revealed even stranger behavior. Unlike Saturn's bright icy rings, Jupiter's rings are faint and dusty. They should behave predictably under gravity and magnetic forces. But Juno observed clusters of particles suddenly shifting direction, accelerating briefly against expected orbital motion before returning to place. The movements occurred repeatedly within the same magnetic corridor extending outward from Jupiter's atmosphere. The reactions were subtle, but far too organized to dismiss completely. One researcher compared the motions to signals moving through an instrument rather than debris drifting through space. The deeper Juno studied the Great Red Spot, the stranger the storm became. For centuries this giant vortex has raged across Jupiter's atmosphere, larger than Earth itself. Scientists believed it was slowly weakening. But Juno's observations suggested something entirely different. Deep temperature fluctuations emerged beneath the storm while the visible outer winds remained stable. During one orbital pass, instruments detected a sudden thermal surge rising from the center of the vortex in less than a minute. At another moment, a stream of heated gas extended outward from the storm like a giant atmospheric filament before disappearing into Jupiter's surrounding cloud bands. Instead of fading, the storm appeared to be stabilizing itself. Jupiter's powerful jet streams added another layer to the mystery. Within the chaotic cloud regions of the northern hemisphere, Juno tracked atmospheric motion patterns that formed repeating geometries. Spirals, mirrored curves, and fractal-like structures appeared again and again inside the turbulence. Motion analysis revealed loops that repeated according to Jupiter's rotational timing, while smaller systems divided into precise fractions of those cycles. The atmosphere seemed to move with mechanical rhythm rather than random turbulence. Some researchers described it as a planetary heartbeat hidden inside the storms. One of Juno's most important objectives was to study Jupiter's internal structure and determine how water was distributed throughout the planet. But the data produced a major contradiction. The deeper layers appeared strangely depleted of water where scientists expected large concentrations of heavy elements and ice. Instead, Juno recorded massive thermal signatures buried far beneath the visible atmosphere. The readings suggested enormous regions of rising and falling material moving vertically through the planet like slow-breathing currents. Some scientists proposed unusual convection systems. Others quietly admitted the structure did not fit existing planetary models at all. Then came the event that intensified speculation surrounding the mission. During one of Juno's later orbits, communication with the spacecraft stopped completely for just over 3 seconds. No hardware malfunction was detected. No radiation spike explained the interruption. The blackout occurred directly above a region where unusual magnetic resonance had already been observed multiple times. NASA publicly described it as a temporary telemetry delay, but internally the event raised concerns. The silence was brief, precise, and deeply unsettling. Now Juno approaches the final stage of its mission. Soon the spacecraft will descend into Jupiter's upper atmosphere and be destroyed forever. Officially, the ending is necessary to avoid contaminating Jupiter's moons. But after years of discoveries that challenged expectations, some wonder whether the spacecraft is being pushed away from something humanity was never meant to fully understand. Because Juno did not simply observe storms, radiation, and gravity. It uncovered rhythm, coordination, systems hidden beneath layers of clouds and magnetism, moons that appeared to pulse in sequence, rings that shifted with impossible precision, cyclones that concealed emptiness beneath their centers, patterns repeating across an entire planetary network. Maybe Jupiter is only a gas giant shaped by natural physics. Or maybe it is something larger, older, and far more complex than anyone imagined. A planetary machine hidden in plain sight, waiting silently at the edge of the inner solar system. The closer Juno moved toward its final descent, the more unpredictable Jupiter became. Engineers expected worsening radiation damage, corrupted images, and failing instruments. That was normal. Juno had spent years inside the most hostile magnetic environment in the solar system. But what began happening during the spacecraft's last orbits did not resemble ordinary system degradation. The anomalies appeared selective, almost targeted, affecting only certain instruments while leaving others completely untouched. And each disturbance seemed connected to specific regions deep within Jupiter's atmosphere. During the late polar pass, Juno's ultraviolet spectrograph captured one of the strangest auroral events ever recorded on a planet. Jupiter's northern lights suddenly intensified into enormous glowing rings stretching thousands of kilometers across the atmosphere. But unlike Earth's auroras, which shift chaotically with solar winds, these formations stabilized into repeating geometric structures. For nearly 14 minutes, the patterns held their shape before collapsing back into turbulence. Scientists initially blamed magnetic interference, yet frame-by-frame analysis revealed symmetrical intervals repeating with mathematical precision. Some of the shapes resembled spirals nested inside hexagonal boundaries, almost like circuitry spreading across the atmosphere itself. Then came the radio emissions. Jupiter has always produced powerful radio waves. In fact, its magnetic field is so immense that it generates emissions detectable from Earth. But Juno's instruments began isolating narrow-band bursts unlike anything previously recorded. Instead of random noise, the signals repeated in structured intervals separated by exact timing gaps. Analysts compared the emissions against known natural plasma oscillations, but the sequences did not fully match any recognized pattern. One signal repeated every 23 minutes with almost no deviation. Another appeared only when Juno crossed specific magnetic latitudes. Most disturbing of all, some bursts seemed to echo back after transmission delays too short to be explained by reflection from Jupiter's moons. It was as if the planet was answering itself. At the same time, Juno's gravity measurements uncovered another impossible inconsistency. Beneath Jupiter's atmosphere, the spacecraft detected uneven mass distributions moving slowly through the interior. These regions behaved unlike stable planetary layers. They shifted over time, drifting beneath the clouds as though enormous structures were circulating deep inside the planet. Researchers proposed superheated metallic hydrogen currents, but the movements appeared unusually organized. Instead of random convection, the masses traveled along repeating pathways that remained stable across multiple orbits. Jupiter no longer looked solid beneath its chaos. It looked active. Even Io continued behaving strangely. New thermal scans revealed fresh eruptions beginning only moments after magnetic surges passed through Jupiter's equatorial field. The timing became difficult to ignore. It was almost as though the Moon was reacting to instructions carried invisibly through space. Volcanic plumes rose hundreds of kilometers high, releasing enough energy to power entire civilizations on Earth. Yet many eruptions followed repeating cycles that aligned not with Io's orbit, but with Jupiter's own rotational timing. The giant planet and its moon system were acting together. As Juno crossed the night side of Jupiter during one of its final approaches, the spacecraft captured images of immense lightning storms hidden beneath the upper clouds. But unlike previous observations, these discharges did not spread randomly through the atmosphere. Several bolts appeared to converge toward the same location deep below the cloud tops, as though energy across entire storm systems was being directed inward. The convergence point vanished moments later beneath dense cloud layers, leaving behind only darkness.